Again, I welcome you all for our next session or the second session that will be taken by our speaker, Dr. Devasis Das. Now he will going to take the session and will give us the input on the machine learning algorithm for he will discussing the machine learning algorithm for the data science. Over to you, sir.
Okay, thank you. So, thank you, madam. So now I'm going to discuss the machine learning algorithm for data science. Okay. So, what are the machine learning algorithm and how we apply this machine learning algorithm in the case of data science? Okay, data science means different application. The applications data science algorithm means basically the data science means basically the collection of data, and those data is either interrelated data or simple not related data also. Okay, so those data either you can collect the data from the your social media, or you can collect the data from the environment. Okay, or you can collect the data from the like from YouTube. Okay, and you can collect the data from the some image sources or something. Okay, so it means data means in the form of text, in the form of image, or in the form of your table, or in the form of your video. Okay, so anything. Okay, and how we apply the machine learning algorithm. So traditionally, if we not discuss the in depth or something, okay, so now the in general machine learning algorithm means like either supervised or unsupervised or reinforcement based learning algorithm. And for the basically what is our objective? Our objective is basically the predict the something. Okay, and with the user friendly way. Okay, as well as we also check the correctness of the prediction. Okay, and accuracy of the prediction. Okay, so these are the basically our objective. Now you like if your application is related to the border line area. Okay, so in the border area, so you want to identify the movement of the soldier or something, some unknown activities. Okay, so then your data means some images, or there is a possibility that some videos. Okay, okay, so this type of information, so you're based on the your application, you have to identify the which type of data you want to use. Okay, then which algorithm is suitable. This is supervised related or unsupervised or enforcement. Okay, so it is labeled data or unlabeled data. Then these are the basically your primary requirements. Okay, so most hot topic in today's day today's is on the social media. Okay, and as well as the environmental thing. Okay, so now in this case I'll discuss the this thing, the environmental event. Okay, so environmental means like the in the city, so what is the traffic condition. Okay, and in the city, uh, in the city, what is the your traffic condition of the city. Okay, and then you identify the it is in the mm, weekday or weekend. Okay, so based on this you can predict the this value. Okay, so now the concept is sometimes the traffic is too high. Okay, what is the reason for traffic is too high? There is a possibility some event occur, the some event or something, the something is not normally occur. Okay, so then due to the some like the due to the some program or activity. Okay, or due to the some means event, sports event or something. So now due to this there is a possibility that some high means the traffic is and the traffic condition is too high. Okay, so now this type of behavior, if there is another one normal behavior, traffic means it is acceptable. Okay, and abnormal traffic is under not acceptable, because it will the sometime the delay for the travel or some other thing also there. Okay, so that's why what is our objective? Our objective is we identify the unnormal behavior is not for the environment. Okay, unnormal behavior. Okay, or abnormal behavior basically. Okay, abnormal behavior from the environment. Okay, so environmental thing, so some of the environmental thing we identified, and we identified the abnormal behavior of those things. Okay, and abnormal behavior means basically the not like the normal behavior, and we predict the abnormal behavior, and due to the abnormal behavior there is the possibility for the losses of our society. So we have to identify the abnormal behavior. Okay, so this is the, so same thing you can do in the case of your so here we can collect the data either in the form of text or in the form of images or in the form of video. There is a possibility. Okay, but here in our application we collect the data in the form of text only. Okay, because the computation thing is and the not required. Okay, in this case not too much, but in the case of images and in the case of your what is this, in the case of your videos, it will take the more computation time. Okay, and computation cost also. Okay, so in this case, and this type of thing also apply in the case of social media, because social media also you have the large number of user. Okay, so then the large number of user and you can easily uh, identify the some behavior is and different from the normal behavior. So you can identify them there means like the abnormal behavior user, or sometimes it is known as an anomaly. So same thing here also I mentioned, if the traffic is on the your uh, traffic is your the not normal, like the not like the normal days. Okay, what is the traffic is required in the case of weekdays and in the case of weekend, but it is the behavior is something different from the weekend and weekdays, then it is the abnormal traffic. Okay, so this, so what is our objective? So we apply on the data. Okay, so we apply the some algorithm, and this algorithm on the data. And what is the data? Data is either, if your application is related to the social media, so social media related data. If your application is something different, so then the this is the basically a different data. Okay, so now here the this application is related to the smart environment, so it is the smart city or smart environment related data. So here we apply the data fusion approach or data fusion algorithm to predict the urban anomaly. So urban anomaly means traffic is another one parameter. We also identify the similar type of parameter. Okay, so I'll explain in details. So like we identify the point of interest in the urban area. What are the top restaurant? Okay, so restaurant also the in the point of interest. Okay, so like this type of thing we identified the data fusion thing to predict the urban anomaly. Okay, sometimes the traffic means uh, sometimes the your traffic behavior is on the abnormal compared to the weekdays and weekend. Okay, so then how we identify those things? So this is the basically prediction. Okay, there is a possibility some accident is occurred. Okay, due to this there is a traffic is too high. Okay, so like this type of scenario we have to identify using the data fusion algorithm or data fusion approach to predict the urban anomaly. Okay, so this is basically, so this is the urban anomaly are the, what is the urban anomaly? Just I explained, the urban anomalies are the abnormal event like the congestion, crowded gathering, crowd gathering, road accident, natural okay, it means like the climate change, okay, or climate that cause the disturbance of the society. In the worst case, they may be cause of the loss to the property or life. Okay, so this is the in general concept in the case of your anomaly, okay, or urban anomaly. Okay, abnormal event like the congestion, crowd gathering, road accident. Okay, so these are the concept. Okay, now the prediction of those anomaly, why this thing is needed? Prediction of this anomaly is the early stage may prevent the some significant loss and help to government to maintain the urban sustainability. Okay, so what is our objective is, these are the anomaly is clear. Now why we want to predict those anomaly? What is the reason for the urban anomaly? Because the due to the, if we identify those anomaly in the early stage, okay, so then there is a possibility prevent from the significant loss and help to the government to the maintain the urban sustainability, like in the case of accident. Okay, and in the case of your crowd gatherings. Okay, so this thing is under basically. So now the prediction is under different kind of urban anomaly is difficult because the dynamic in nature. Okay, so anomalies are also dynamic. So these events are also dynamic. Okay, because the sometimes the means if you know the every day the traffic of this region is under 10 means 10,000, then it is acceptable. You continue for the 7 days the 10,000, but it is not like that. Okay, So holidays versus weekend, weekdays, okay, and your as well as the office versus the shopping mall. So these anomalies are totally different, and pageants in the different form. Okay, so like the in the case of road congestion may be caused the blockage of the yeah, block due to the accident or due to the driveway. Okay, so there is a possibility multiple forms. So what is the basic concept? We have the urban anomalies, those behavior is under like the abnormal. Okay, and prediction of those anomalies are the very important job based using the data fusion technique or data science algorithm. Okay, and this is basically help for the prevent the significant loss, and which is then basically the help to the government to maintain the urban sustainability. And those anomalies detection is on the, so our prediction is there. Okay, but prediction is difficult. Why it is difficult? Because traditional model is not suitable for this environment. Okay, if you want to apply the like your simple traditional neural network model, then you are not getting the enough output. Okay, because their form and their complexity is more. Okay, so then because they are in the dynamic in and as well as the pageants in the various form. Okay, so now in this work basically we propose the novel hierarchical framework. So we want to implement the one or introduce the one hierarchical framework and uses the data fusion approach. So our objective first one framework, and we uses the data fusion approach or algorithm to predict the urban anomaly from the multiple from the data. Okay, or multi-streaming data means we have the multiple data sets, so we can use this thing. Okay, and first, so what is this? So here we are using the graph a neural network type of concept. Okay, so first we convert the city region into the graph neural network. Okay, so city region means city is divided into the region into the graph neural network, then capture the inter region spatial information using the gated graph convolutional neural network. Okay, and to utilize the temporal correlation. Okay, because we are using the both thing, spatial information means space related information, as well as we are using the temporal correlation means time related information, and we can use the combined gated with the context aware mechanism to assign the different historical event. Okay, so this is either accident prediction or your this thing the event prediction. Okay, and here we are using the some attention layer type of concept. Okay, which basically capture the important information to prediction the spatial and temporal embedding embedding layer. Okay, temporal embedding layer. So we also here added the one extra layer, name is the attention layer in the model, so modified version of the model. Okay, graph neural network is there, but as well as the we included the gated concept, we also included the convolutional concept, and as well as the we consider as and the also we had the one extra layer which is on the with the neural network layer. Okay, means hidden layer, traditional hidden layer using the neural network concept, as well as the attention layer, which is basically responsible for not collect the all information, capture the important information for predicting the spatial and temporal embedding layer. Okay, and here, so in this case, so data collection, okay, so data collection, so we are using the here not very complex thing. So in this case we are using the real world data set. New York City data sets are available. So here we, because we want to use the multi streaming data, so that's why we are data set is the urban anomaly. So Newark NYC urban anomaly data set, which is related to the anomaly related information is there. NYC POI, point of interest, means the student shopping mall related information. NYC is road network, so yes, road related information is there, road condition. Okay, and Newark data sets for the Newark data city data set for the weather weather data set for the network city, collect using the smart devices. So they collected this information using the smart devices across the city to evaluate. Okay, to evaluate their city related informations. Okay, so here we are using those data set, these 4 data sets for to evaluate our urban anomaly prediction framework. Okay, and this is the basically this is the data set. Now we are using the this gated convolutional graph neural network concept, and using this we finally trained our model. Okay, and then we measure the we measure the performance of our system in the terms of f measure, in the terms of macro and micro f. Okay, macro and micro think of f1 f measure. Okay, and as well as the state we compare with the state art as well as the baseline model both. Okay, so this is the basically our whole diagram. Okay, so now you can so here in this case here we are using the gated convolutional network. Okay, and here your road network related information stored into this data set. Point of interest means your restaurant, movies. Okay, and urban anomalies. Okay, and we apply into the this concept here. In the case of here we are using the concept of intra and intra region concept, and here we are using the divided into the tasks. Okay, and urban anomaly we are using the this concept. Okay, and finally we embedding with the weather condition and global attention layer, because just I mentioned the attention layer. Finally the perception, multi-layer perception also we are using, and finally we are getting the our output means accuracy of the system. Okay, for the means prediction as well as the accuracy of the system. Okay, so prediction means what type of prediction. So this is the urban anomalies is there or not. If there, then what is the prediction rate. Okay, so urban anomalies is in the behavior. In the case of road network is different. In the case of point of interest is different. In the case of urban anomalies also the different, and in the case of weather is and the also the different. But here we are, why we are using the different models, because their behavior and nature also the different. So we identified the suitable solution. Okay, so like the here we are using the gated GCN. Okay, and here we are using the GRU. Okay, gated recurrent unit. Okay, so these are the basically based on the application, and based on the our data set we identified these are the suitable model. Okay, and then the finally our objective is and the using the global attention layer and multi-layer perception, and finally the prediction. Okay, so this is the basically in details concept. Okay, so now evaluation. So how we evaluate, this is the basically main challenging job in the case of any algorithm. Okay, so any your machine learning algorithm for data science, these 5 features is and the very important. Your either in this case our application is on the urban anomaly, your application is anything. Okay, you can identify the nature of the your institution or your organization of the networks behavior. Okay, or sometimes the behavior of the your different anomaly in the case of social media, social network. Okay, so this is the, but this 5 question is on the, it is mandatory. How does the our framework, means we propose the one framework as a compare the baseline technique is and the predicting the anomalies. Means baseline techniques means you have the traditional machine learning algorithm like the SVM and decision tree. So how this our framework is and the compare. So somehow your framework is good in the terms of performance, or in the case of performance means somehow using the F measure we already perform this thing, or using the accuracy. So first we check the this, we design this framework. This framework is suitable for the implementation, and as well as the performance is better compared to the baseline techniques. This is the first question. So then but nowadays everyone applies only the baseline technique and compare the all these baseline technique, and finally they identified the okay decision tree one is and the performance is too high, this is the suitable solution. But in general it is not. Okay, it is based on the only baseline. So you have to, so here we implemented the one new model. Okay, and this model is basically compare the all baseline model and achieve the better performance. Somehow you have to design the such type of model, it is mandatory. Otherwise this is all existing technique. Okay, how does our framework is compared with the state art of the technique in the predicting the anomaly? First one is baseline. Now the state art of the technique, because some of the techniques are available, they already implemented something as a social network prediction or something. Okay, but their case basically their concept is they are using the concept of state art of the techniques, means basically they also modified something. Okay, they also modified the sum of the parameters. They also modified the number of layer. So these are known as the state art of the technique for the predicting the anomaly in the case of urban, or basically in the case of social networking anomaly. Okay. Now after that, so first our objective is we have to design the one framework which is basically comparable with the baseline model, anomaly prediction model, and we also design the framework which is compare the state art of the techniques model. Okay, and also we can what is the performance. Okay, we also check the performance of our model. Okay, urban anomaly is the name of the model to predicting the particular anomaly category. Okay, so anomaly category means we categorize in the 4 types. Okay, what are the types? Type is in the your either the road network or point of interest or urban anomaly or your weather condition related information. Okay, then how does different parameter setting affect the performance of the push scheme? So if you want to change the parameter setting, then how it is affect to the your performance? Okay, if you want to increase the number of layer, you want to increase the your features, so then how it is affect to the your performance? It will increase the your accuracy or decrease your accuracy in the terms of F measure. How the performance varies and the different combination of the module in the joint architecture. Okay, so because here we integrated the 4 types of different architecture and integrate them, and then the using the perceptron thing. Okay, so then how it is attention layer is responsible for the integration. Okay, then how we integrate them and how the perform if we integrate like the different way, because here if you check, we directly integrate this thing into the weather to here, because here we achieve the good performance like the this way integration. Okay, so you have to check the which type of integration is and the suitable for your applications. Okay, so this is the basically 5 reason for the any. Okay, in this case our concept is on the 4 type of data sets. Okay, so you can consider the single type of data set, or you can consider that your application is related to the social media, or your application is related to the smart city, or your application is related to the smart grid. So all these things are possible. Okay, but based on these 5 types of evaluation, first one is your baseline model you have to check. Then you check the state art of the model. Then you have to check the predicting the particular category. So which category anomaly you want to predict. Okay, or which category application. So application is very important. Then the what are the parameter setting for those application, how you tune the parameter, how you tune the model. Okay, then the finally you check the how you integrate the all this model combination of the all this module, how you join them into the architecture. Okay, so from the audience, if you have the any doubts, any query regarding this 5 types of evaluation. Okay, for the this is the important thing for the any machine learning algorithm for the data science.
I think no queries, sir.
Okay, so then the what is the experimental setup? Okay, so in this case, so you have to have the data set. Okay, otherwise you can use the some device to collect those information. So first one is under your data set collection, means data set is required. Okay, then based on the data set you have to the set the your parameters. Okay, then the which parameter you want to retrieve. Okay, then the third one is on the baseline thing. What are the baseline model you want to use? Not like the you have the large number of baseline model, but you check this is supervised one or unsupervised one or something. Okay, then the evaluation split and performance measure. Okay, now this is the data set statistics. Okay, so this is the urban anomaly data set. Okay, here this is the category. Okay, so urban anomaly means basically the like the blocked driveway, noise, illegal parking. These are the category. You can include the means if the some data sets or some other data sets they also have the more number of categories. Okay, or you can create the your own data set and you can categorize them based on the your requirements. Okay, so here this is the because we are using the this data set, so that's why the our category is only 4 types. These are the instances we collected. So large number of instances means basically the event. Okay, so these are the instances for this type of anomalies. Okay, same the point of interest. Point of interest, we are categorized like this. You can include the more types of categories. So we categorize, just I mentioned, the food and dining, health and beauty, government and community, okay, education. So these are the point of interest and these are the instances. These are the available in the case of your data set. This is the very important thing, okay. And same thing for the your point of interest, and as well as the same thing for your road network, and same thing for your this one is also the available, okay. So now the our what is our objective? Objective is, now we are using the comparing this thing with the baseline model. So these are the baseline model, okay. So these SVM, linear regression, okay. So these are the baseline model, and based on the baseline model we also calculate the this 4 parameter accuracy, precision, recall and F measure, okay. And also we compare with the same data sets, and we here we check the, this is the predicting the urban anomaly, okay. So urban anomaly data set, this data set, and using the urban anomaly data set, if we compare with the baseline model, and this is the accuracy, okay. So now in our model also the accuracy is in the urban anomaly is in the proposed model, which is basically I just mentioned based on the gated recurrent network, okay, gated conventional neural network concept, okay. So this is the accuracy is little bit high compared to the all others baseline model, okay. Now what is our next concept? Next concept is we have to compare with them with the our this model with the our other models, means straight out of the models, okay. So so this is the same thing in the baseline model, and why here we are using the uh, comparing the different categories, okay, and month wise, okay. So this is, and this is the your straight out of the model. So these models are available, okay. So these models basically the they also predicting the anomaly in the case of social network or in the case of other thing, okay. So and some of them is also consider the anomaly like road network or something, but they're not integrated like this way, okay. So in their case also accuracy level is not very good, okay. So somehow our case it is and the improvised better than the all this existing one. And we also consider here the for the performance measure purpose accuracy, precision, recall and F measure, okay. Now the performance validation, okay. So validation one, okay. So here the validation one, if you check, so we consider the only the 2 months, okay, 2 months data like the December and November, okay. And this is the prediction of the results of anomaly category, and these are the basically your first A, B and C and D, basically these are the basically your 4 figure. One is related to the noise, second one is on the illegal parking, third one is on the building or uses, okay, and fourth one is on the blockage driveway, okay. And different categories of the, these are the baseline model. So baseline means either SBM, linear regression, recurrent neural network. So these are the baseline model, and if we compare, we here we check the, this is the performance is on the too high and compared to the all existing baseline model, okay. And sometimes there's a possibility sometimes their performance, because data are different, because in the noise the data are different, in the case of illegal person parking the data are different. So these model all other baseline model sometimes it will vary, okay. But here in this case basically but in our case every time we achieve the better performance compared to the this based on this data set, okay. Then the then parameter sensitivity, okay. So parameter sensitivity is in the, if we check the macro and micro thing, okay. So then the in this case also performance is basically, in our case it is basically better, okay, compared to the all existing schemes, okay. Now we compare this thing with the our baseline, means basically the state art of the models, okay. So states art of the model, if we check, so here basically these are the different layering concept, okay. So like the your simple recurrent neural network and with the anomalies, okay. So this is on the based on the comparison. So here if you check, then this model, okay, gated recurrent unit is perform better compared to the LSTM and as well as the in the case of recurrent neural network. Okay, and here also the this is the effect for the your context informations. Okay, so context information wise also the this is on the different models. Okay, we context information wise this is on the F measure. Okay, so these are the parameters basically. Okay, so here also the recurrent unit wise selection. Okay, so recurrent unit wise also the performance is better in the gated recurrent unit. Okay, so now this one is under what are the challenges in this case. So here if we check, the first we compare with the this technique with the prediction of the anomalies. Okay, so with the baseline techniques, then the second one is on the state art, third one is on the your own performance based on the your own scheme. Okay, which one is you want to propose. Now my question is here, how you identify that these baseline techniques, how you identify that these baseline techniques. So from the audience side, any information about this? The how you identify the baseline, which baseline is more suitable, and you identify the this baseline is good. How you identify? How you identify the baseline models, which baseline models are more suitable for the prediction? How you identify? Because a large number of peoples also the work on it, as well as the all the universities have the machine learning courses. So how you identify the these models are good, which model is good, like in the terms of supervising? Any idea? So in this case, this model selection is based on the your applications. Okay, so what is the your application, and how what is your features selection? Okay, and features are how they related to each other. Okay, this thing is the very important thing. Okay, so like in the case of in this example, so we consider the urban anomaly thing. Okay, based on the some parameters. Okay, parameters, and based on this concept the category and instances. Okay, so if we increase the number of category, okay, categories, so then there is a possibility in our case the performance is good, because we consider the more categories. Okay, then the our instances also the more, enhance the number of instances, so then the accuracy level also the good in this case. Okay, so like this type of you have to identify, when you identify the this baseline model, you have to consider the following thing. But in general the SVM and decision tree and linear regression, these are the basically perform in the terms of accuracy is good. Okay, in the case of different environment, different applications. Okay, so all of the application basically they are basically model, and their this structure is provide you the somehow the accuracy level is and the little bit high compared to the others model. Okay, so in general we consider the this thing. Okay, but how you identify the this thing, like the framework to compute the state art of the techniques? Okay, so now this is the basically difficult job. Okay, so why it is difficult? Because baseline, you know, you already read, you understand the okay, and large number you only the identified the few of the baseline thing, and you only identify the sum of the out of 10 models, only the 6 model or 4 model which is related to the your prediction thing or anomaly detection thing. Okay, so like you have the large number of models, but you only identify the either SVM or linear regression and the decision tree, only the 3, then it is enough for the baseline thing. Okay, and this is already available, and codes are also available in the case of this 3 model, and you can easily execute this thing based on the only you change the your data set. And because some codes are available based on their data set, only you change the data set and we included the new the urban anomaly data set, then you can execute it and you easily check the what is the accuracy level or F measure as well as the recall, precision recall. Okay, now the question is, in this case, the how you identify the state art of the techniques. Okay, this is the difficult job. Okay, so state art of the technique for the anomaly prediction. Okay, so now urban anomaly prediction, if the no walk is available in the case of urban anomaly, if no walk is available, then how you identify the this thing, the your anomaly detection state art of the technique. Okay, so then if available, then it is good, you identified the one or two technique which is and the more cited, more popular thing. Okay, and with the recent year 2019 2020, if not available, then you have to check the similar means anomaly prediction thing is available for the social network analysis or in the case of other networking or other areas. Okay, like the sometime it is available for the AR VR, augmented reality or virtual reality. Sometime it is available for the prediction technique for the banking system. Sometime it is available for the prediction in the case of your environmental solution. Okay, so you have to collect those state art of the techniques. Okay, so you identified like the three state art of the technique, A1, A2 and A3. Okay, one is related to the social networking, one is related to the your environmental, and another one is related to the banking. Okay, now the question is how you implement those things. Okay, because those codes are not available. Okay, baseline codes are available, so this is the challenge. Okay, so then the first concept is concept if available to the using the your this code is uploaded in your GitHub, then you collect the code. If not available, okay, so then you have to implement their model, okay, based on their logic in your environment, then you check the accuracy. Okay, sometime it is available in the case of GitHub, so you collect those codes. Okay, and then you request to the corresponding authors to collect the code. Okay, then you change your data set, because your data set is on the urban anomaly, you change the all parameters, then you execute in your system. Okay, when you execute in your system, then you achieve the some performance which is somehow little bit better to the baseline model, because baseline models are very old. Okay, and they basically perform based on the some they are the baseline model, and this is on the basic understanding thing. Okay, so then in this case, when you this thing is state out of the model, so you have to implement those things. Okay, so then you check the accuracy, either implement those things, or you, if the codes are available in the GitHub, then you check. Now the concept is on the in your case, so in your case you your model is you already implemented. Now if you execute the code and you achieve the some performance which is better than the baseline but not good in the terms of state art of the techniques. Okay, if not good in the state art of the techniques, so then what is the problem? Somehow the your identified model is not suitable for this type of data. Okay, or for not suitable for this type of data pattern. Okay, so then what happened? So either the concept is in this, if you check the accuracy level is on the like similar to the baseline model, and after tuning and after you changing the layer and anything, then also the improvement is not acceptable, then you think for the other models. Okay, and other models means then you think the base data sets available and features available, which model is suitable for this type of concentrate on the like the state of the models. Okay, if the state of the model they using the one model A1, which is using the concept of multitask learning. Second one is on the multitask learning with neural network, and third one is on the uh, like the mixture of a multi-gated mixture of expert model. Okay, so then you think that in this case, if they are using these three models, and they are out of these three models, somehow multitask learning with neural network is in the deep neural network concept is there, and their concept and their feature selection and your feature selection is more or less similar type of concept, then there is a possibility you enhance this multitask learning with the neural network concept, and they have the basically a concept of your number of layers, okay, neural network layer as well as the attention layer, okay. So you have to modify the sum of the layer, okay, and you have to modify the sum of the parameter setting, and then you apply the your concept and you check the what is the your performance, okay. Then if somehow the performance is similar to the your like state out of the A2 model, which is basically multi-task neural network thing, so your concept and their concept is on the somehow different, but performance is also same, then you think again the any other parameter which is basically enhance the performance of the your system, okay. So you have to tune the parameter or enhance the number of layers, okay. Then you check there is a possibility to the enhance the accuracy or not, okay. And those parameter thing, all these thing is based on the your feature selection and as well as the in your other concept, okay. So this is the basically concept. If you have any question. Hello, so any question from the audience?
Participants, if you have any question, then you can ask now.
So related to the baseline techniques, related to the state art of the techniques, or related to the you want to propose the any model, then what are the requirements or anything? If you have any doubts, anything.
So some queries within the chat box, I think. Is it a good practice for shifting the domain?
So any doubts relating to the machine learning, any baseline model technique? If you have any doubts, any query. Okay, so this thing. So first you have to check that these three thing is mandatory for the any machine learning algorithm for the data science. First one is then the your baseline technique, then the state art of the techniques, okay, then the from the baseline and state art of the technique, when you understand the both thing, then you can design the your own techniques, okay. And this own techniques is either from the your state of the art technique, modified version of the state of the art techniques, or it is modified version of the baseline techniques. But modified version of baseline techniques is the very difficult and achieve the high performance also difficult job, okay. So that's why if you consider the state art of the technique, okay, so then which is basically easy, okay. And you also think the your feature selection thing, and based on the feature selection your model selection also the important work for this type of data means for this type of machine learning algorithm for data science type of concept, okay. And how does this parameter setting, so now a fourth one is how does the different parameter setting affect to the performance of the your proposed method, okay. So your parameter setting means like the basically you have the number of layers, okay, and those layers are connected to each other, okay. So then how they connected and what is the um, thing or input parameter in your input layer, and what is the your output parameter in the case of output layer, okay. So like here what is the input thing? Input thing is on the your different types of your, like in the case of urban anomaly, okay. So urban anomaly means in the case of urban anomaly what is the input parameter? So input parameter we send the blockage, yeah, blocked driveway, noise, illegal parking and building use. So this is on the four input will give into our input layer. Then we have the our hidden layer with including the concept of perception, including the concept of attention, okay. So this thing, okay, attention and perception thing and as well as the traditional neural network computation is there in the hidden layer. Okay, and we have the architecture like the 6 to 8 layer based architecture, hidden layer based architecture, and we have the one input layer and we have the one output layer. Then after this 6 to 8, or in general the 6 in hidden layer is responsible for compute this thing. Okay, and finally what is output? Output you are getting the, this is under how many anomalies are there. Okay, and this thing, okay, anomalies and non anomalies related information. Okay, so this is under urban anomalies related information you receive, and as well as you receive the this thing, the some information which is related to the means not like the anomaly, means not like the this is the normal behavior people and abnormal behavior people. Okay, so this thing is under very important, and how you setting the your parameter for the performance. Okay, then how does the performance varies with the different combination of the module join architecture? So if you want to, like, if you only consider the urban anomaly, then it's okay. If you consider the road anomaly, also road traffic, you also consider the weather condition, you also consider the point of interest, then this is the very basically your integration and how the modules are you want to integrate. This is also the challenging job. Okay, so this one is basically very difficult job to this in this case of integration. Okay, so but if you consider the simple concept like the, you only consider the one data thing, so up to 4, 1 to means question 1 to question 4 is under enough for this any implementation. Question 5 is not required when you don't want to integrate the multiple data sets. Okay, only you consider the single data set, and this is the enough thing. Okay, so any machine learning algorithm for data science, you have to consider the this 4 concept. One is that you have to identify the baseline model, you have to identify the state out of the models. Okay, and from the state out of the model or baseline model, you have to identify the one solution which is basically better performance compared to the state out as well as the baseline model. Okay, in the terms of different performance measure. So either you consider the this existing performance measure means like the F measure, precision, recall, and accuracy, or you can implement or you can introduce the new performance measure. Okay, and then you check the what is the performance of the your system, and in your proposed model how many layer and why you include those layer, and how the how you propose the parameter setting, this thing also the important. Then the fourth one is on your performance when you measure the performance. So again you check the your parameter setting thing for your proposed approach. Okay, so this is the in general concept. So if you have the any more questions from the audience. Okay, so then what is the here the what is the conclusion is on the basically the urban anomaly prediction is on the challenging and important tasks to reduce the economic loss for our society. And in this work basically we propose the one architecture to solve the urban anomaly prediction. So one architecture means this architecture is on the multiple parameter we integrated the 4 types of, one is urban anomaly, second one is road condition, third one is your weather condition, fourth one is on the point of interest. Okay, and then the urban area is what is the main concept here. We urban area we divided into the region according to the road network to capture the semantic spatial relationship. Okay, because we also consider the here, because in general in the any real life problem we have the 2 types of solution. One is the spatial related information, second one is the temporal time related consideration. Okay, so here here we first one we urban area we divided into the region, and region means it is basically space related concept. Okay, according to the road network to the capture the semantic spatial relationship. Okay, and we also to incorporate the context aware temporal signal we are using the gated recurrent unit and weather information to the consideration. Okay, then we obtain the accuracy for the 83% or 0.83 in the prediction of the anomaly in the real world data set. Okay, real world data set means because of the, in our case, neural network data sets, means New York City data sets, and to validate the model to performance compared to the proposed model in the various baseline model, as well as the our state out of the model. Okay, so further we evaluate the our proposed framework and different perspective how the individual module will contribute, because we integrated the final results. Okay, but we have to check the these things and the basically the evaluated network. Our network is on the how individual module will contribute. Okay, so some module is contribute more, some module will contribute less, and how the context information play the role. Okay, because our data sets are different environment. Okay, so data set means one data set is related to the urban anomaly, one data set is and the related to the our point of interest, another one is in the road weather condition, another one is in road condition. Okay, so our objective in this case, the in the proposed framework is and the consider the different data. Okay, different types of data and their behavior is also the different. So so how we individual module will contribute, and how the context information plays a role, and how the recurrent unit affect the to the performance, because we also use a recurrent unit, and how the recurrent unit will means affect to the performance. Okay, so these are the basically means this is the in our proposed model, and this is the conclusion. Now what is the future work thing? So future work basically in this case, in future, this is the one thing we implemented in the case of our in armored anomaly prediction. Okay, so also we can try to use the similar type of proposed architecture to the other problem prediction. Okay, which type of problem? We want to incorporate the context, the information simulate to the real world problem. So the multi-domain thing. Okay, so like the multi-domain incorporation maybe increase the accuracy of the model. Okay, and we'll try to the accident data. So we can use the something that only apply the road condition related road network data or road traffic related information, and we also identify from the traffic related information based on the this type of architecture the accident data. We can also identify the crime data. Okay, from the crime data set we also predict the crime thing. Okay, or human mobility data sets. Okay, if we have, then based on this type of model we can predict the mobility and behavior of the humans. Okay, so this is the based on the different application, or based on the different machine learning algorithm you can use for the different types of data or different types of data science thing. Okay, so like the in the case of accident prediction, in the terms of crime prediction, in the terms of your anomaly detection. Okay, so these are the basically concept for the this type of architectures. Okay, and also the you also introduce the new type of models. Okay, and which is responsible for the prediction of the such type of thing. Okay, so this is the overall concept. Okay, so from the audience, if you have the any query, any questions, okay, so then I'll be happy to answer those questions.
Yes, sir. There are some queries in the chat box.
Yes, one second, I'll check.
Sorry. It is visible to you?
One second, no, there's a no query in the chat box.
Okay, I will read them. Sir,
So you directly paste here. It is visible to me.
okay, fine.
Yes. Uh, yes. Either you concentrate on the hard, either you concentrate in general, the data sets are available, some of the urban anomaly related information, or you can use the hardware. Then the if you use the hardware, then you easily detect the anomaly for the specific city. Okay, and you collect the information, you put the hardware to the different location, okay, and then you collect the data. This is your own experimental setting, okay. So then this is it is basically required the hardware. So then through the hardware you can collect the information. This is the real life information, or some data sets are available, and this data set is in the 2014 to 18, okay. So some of old data sets, okay. Based on this data set you can also predict this thing, okay. And computation time is under this framework is basically your data collection thing is there, okay. So data collection, you can use the lightweight device for hardware, okay. But when you compute the whole this thing, collected data, then your high framework is required, high computation system or server is required for the computation, okay. But data collection is then basically you can use the IoT device for the data collection, okay, for the urban anomaly. But when you can use this thing, the prediction thing, or this computation of the whole data set, and your data set is on the huge 1 GB data set or TB data set, so then it is difficult, okay. So that's why this is in the case of data collection, not required any strong hardware. Traditional normal hardware is acceptable, but your computation purpose, you have to have the your enough computation power, as well as your server is mandatory, okay. So in our case, we have the DGX. So through the DGX, you can easily implement this thing. Yes, you can shift the domain. It is also the good practice. But if you domain means it is basically your understanding. Okay. So if you have the interested in the domain, means like the initially you interested in the security. Okay. So now you don't want to of security. Okay. So now you want to move into the machine learning or artificial intelligence or some other domain also. Okay. So then first your basic understanding is required. Okay. So through the basic understanding, if you are the BTech student or MTech student, you have the core courses or elective courses during your semester. You want to take those courses. And if you are the employed person or somewhere, so you can follow some online lecture. Okay. And then you clear the all basic of this specific area or specific domain, either machine learning or computer networks or ad hoc networks or vehicular ad hoc network or smart transportation or your artificial intelligence or security, cyber security, blockchain. You clear the basic understanding, then you identify the new problems. Okay, new problems are also available. Okay, if you check in the good university and good research lab, they also publish the new types of problems. Okay, and you also identify the one problem, and then you understand the problem, you try to solve this problem, then finally this is the basically there is no issue, you can shift your domain. Okay, but basic understanding is required. Okay, so this domain thing is not based on the my knowledge, and I also check some of the students initially joined the PhD. They are interested in the case of they want to work on some machine learning. Okay, so then after 1 year they want to switch, and they also complete their MTech in the project with the machine learning project. But after 1 year they want to switch in the blockchain. Okay, and they are doing well. They publish the top tier IEEE transaction, and they also publish in the top tier conferences. They also receive the multiple awards. So it is not like that domain is specific. Okay, but it is your interest. Okay, and this domain is on the large opportunities is there because the large number of companies, everyone want to apply the machine learning for the prediction. If they predict something, so then which is basically helpful. Okay, so like some mechanical companies, okay, or like the Audis and as well as your BMW, they want to identify the in future what is the security model in their internal security inside the car. Okay, so if they predict something, okay, so then it is easy to develop some system. Okay, means like the concept is, if you know the attackers, okay, what is the behavior of the attackers, then easily you implement the such type of system. Okay, so like in the case of COVID-19, okay, so COVID-19, so no one predict that this type of behavior is possible in the case of one COVID-19 types of virus. Okay, so that's why it will take the designing some this vaccination or something. Okay, and if you predict the previously, okay, like in the year of 2019, like there is a possibility the such type of virus is there, so then easily you develop the such type of system. So any more queries?